Okay, let's jump to the next slide. So here, we are finished with the defining the problem in Open Modelica, and then we are starting to solving this problem using algorithm, much algorithm. First, we applying the cosinus and sinus matrix to our matrix and converting it to a global format. Because we apply the cosinus and sinus matrix to our previous matrix, we get this stiffness matrix. And after that, we convert that stiffness matrix into global format. And we here we convert into global format. First, we solving it here, and then we transforming to global matrix. Me and Infranavis has already settling this code up in Open Modelica. And then the last step is to uh, combining the all global format, a global format matrix. I mean, yeah. So let's jump to the next slide. And then we here can apply the boundary conditions for the truss. As we see here, for I in boundary loop and for J in I titik 2 n loop, G in matrix G I comma J equals I D I comma J and 4. And also our purpose on the start is to find the displacement and also the reaction force. And here's the formula that we can put into Open Modelica, that displacement equals to modelica.math.matrix.solve. Basically, we use solve function from the Modelica math matrix using parameter G and F, using parameter global matrix and the forces. And that's the displacement. How about the reaction force? Reaction force is equals to G star times the displacement. It is the displacement. And then after that, we subtract the F from it. Yeah. Okay. Okay. Don't forget to eliminate the floating error. Of course, we create this call function to eliminate the floating error. And here it's written for I in 1 and loop reaction I if absolute reaction I minus than or minus equals error, then 0 else reaction I. Displacement I if absolute displacement I minus than error, then 0 else displacement and 4. And that's the end of the function, call function there. So after we settling up the Open Modelica before, and then we simulate it, and it went properly, here we get the displacement graphic of our problem in the first. Here we can see it's 0 and it's fluctuating from, it's going down and it's going up, it's going down again. As we can see here, it's the displacement graphic and it's the reaction force graphic. So we can see on the boundary, on node and node to entry in the left, we can see the reaction force is quite high, and then it's going down and it goes up again. Maybe I assuming this in the force point on the node 4. I mean, okay, that's all from me. If there are any questions or any mistaken, please contact me for furthermore dialogue. You can talk to me about what is wrong and what the mistake. Okay, that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.